Hey guys, I'm Chris from True Fun Entertainment, and in my last video I announced that I am officially porting Mortal Kombat to the Atari Jaguar. So today I wanted to give you guys a little update as to what progress I've made since the last video. Then we're going to do a deep dive into texture atlases, or sprite sheets, and how they power all of the animations in the game. And then how I'm actually piggybacking off of those animations to build what I call impact frames, or how the collisions are detected between the fighters and doing damage to one another. So we're going to do a deep dive on that, a little bit of a code review, and then I want to show you kind of a big breakthrough that I've had in building the game. I knew it was something I had to tackle, and now that it's done, I think it could actually lead to some Jaguar exclusive content, which would be pretty cool for this build of the game. Before we get started, I want to take a quick moment and thank the Patreon supporters. So in the last video, I announced that we're starting a Patreon to support the development of this game. Already we've had people sign up, and you guys have been great in providing feedback and also really encouraging me to stick with this project and keep going. All right, so we're pulling up the game here, and we're going to take a look at the progress that's been made since the last video. I'll select my fighters. Let's do, let's see, Johnny Cage,
Subzero,
and Subzero. Still don't have any text yet on the battle versus screen. Haven't tackled fonts yet, but we'll get there. We have the fight zoom in, and now, as we showed in the last video, we can move fighters around. We can scroll the backgrounds. I'm still not handling the camera movement. You can kind of drag the player along, but we'll get there. But in the last video, we showed that you can move the fighters around, they can duck, they can block and duck. But now we have the ability to attack. So Johnny Cage can low punch, low kick, high punch, and high kick. And then Subzero can do all the same as well. But we now have, and I kind of showed this off in the last one, we have these hitboxes that are set up. So the logic behind the scenes is all happening with these hitboxes, not with the fighters themselves. So we can see as we move around, there's hitboxes. If I duck, we hide that top hitbox for Johnny Cage, so only the bottom one's there, so that he could like duck projectiles, duck punches, things like that. So, and then if I actually do a punch, you can see for a quick frame, there is a hitbox, and then we can use that to see if he's colliding with the other fighter. Now, the frame that hitbox shows up, I'm calling those impact frames. So basically, and we'll get into texture atlases and how animations play out. And then a certain frame of animation is called an impact frame, where it has a hitbox attached to it, and we check if that collides with the other player. And as we can see, if it does, damage is done. Okay, so if I hide these, we can see kind of what we're doing here. And then if I do a high punch, we actually get some blood. So I'm going to come over here and show off a high kick. So we are actually showing a droplet of blood, which is pretty cool. That was fun to animate. This is Mortal Kombat after all. So to actually get blood in the game was a pretty cool concept. And I can kick him back. There we go. So, and this actually got me to thinking opportunities that we can build into the game and kind of make this version of Mortal Kombat our own. So, if you're not familiar with the Jaguar library, there was a game, it was kind of Atari's answer to Mortal Kombat called Kasumi Ninja. And Kasumi Ninja, it got kind of less than stellar reviews, but as a Jaguar owner, I thought it was pretty cool, and I enjoyed it. But one of the aspects of the game that was pretty cool was, it had all the blood and violence like Mortal Kombat, but the blood actually stayed on the ground in Kasumi Ninja. So I always liked that. I thought it was pretty cool. One of the things I'm going to put up to kind of a Patreon poll to get your feedback is, should we do like a Kasumi Ninja mode in the game where all the blood stays there for the entirety of the match? So, by the end of the match, the whole stage is going to be blood stained, and it might be a pretty cool mode that only exists in this version of the game. So that's the major progress that's been made since the last video, is we're actually starting on the combat system. We have the ability to do 4 attacks, the low punch, low kick, and high kick, and actually impact the other player. So now we're going to hop over to texture atlases to kind of show how these animations are happening and how we piggyback off that to build these impact frames to actually damage the other fighters. Okay, so back in my original video where I built that prototype of just the character select screen, I was using the out-of-the-box animations with the Raptor API. And the way that works is you can stack all of your frames of animation into one image, and then it iterates through the frames top to bottom. And then you can give it kind of the delay between each frame. But I knew when building all the frames of animation for Mortal Kombat, I was going to need a more complex system to handle all of the animations. So I reached out to folks on the Atari Age forums, and they had mentioned the concept of a texture atlas, which I have used in previous games. I just didn't know it was possible with the Raptor API. So, but essentially what you do is you have one image with all of the frames of animation. Then you have kind of a windowed view of that frame with a set height and width of the frame, and then you can traverse around that image to have the different frames of animation. So we can see here the first, we're looking at Johnny Cage's walk animation, and this is the first frame. We can see it's at X768 and a Y of 0. Now if we advance it one frame, we move over to the next frame at 864, and it has that frame 2. So now if we were to put this all together, we can see to get Johnny Cage walking, we're iterating through 9 frames. Now the cool part is I built a kind of an animator where I can specify not only the frames that go into that animation, but also does it need to loop? Does it need to play forward? Does it need to play backwards? Does it only need to play once? So for example, this is just a looped animation going forward. And this has him walking forward. But if I were to specify I want it to walk backwards, that's just saying play this animation in reverse. And it's looping, obviously. So if we go back to a static frame here, next to the walking animation, you can see here's the 3 frames of animation for Johnny Cage ducking. And this would be an example of an animation that we don't want to loop. So when he goes to duck, we play the 3 frames of animation, and then we stick on that last frame, which is him ducking. Then if we release the down button, we want him to stand back up. So we would play that same duck animation in reverse to have him stand back up. All right, so we're over in Visual Studio, and I kind of wanted to show you guys how this texture atlas and animation handler works under the hood. So, and this is C code that we're looking at, not C++, not C#, this is just straight C. We have this concept of a struct, which is basically a way to encapsulate chunks of data. So this first thing I have here is this struct of an animation frame. So that each frame of an animation has a height and a width. So that's the actual cell of animation. So for instance, Johnny Cage has a width of 96 and a height of 144. Then this frame needs an X and Y coordinate of where on that image, where on that sprite sheet we're going to have this frame. Then there's an offset for X and Y. That's a little bit more advanced things, but basically some of the fighters don't take up like a full 96 width. Like Scorpion and Subzero are pretty, their width is sometimes as low as like 48 pixels. So in order to keep that centered, I have to have an offset. And this offset allowed me to save memory with the image that I can compress more of the frames together and then have them play visually correct by having this offset. Then finally we have the ticks. So with the Raptor API, this is a way of keeping time. It's kind of a heartbeat as the game is running. You have what they call rap ticks. And this is based if you're doing PAL or NTSC. So if you're in PAL, you'll get 50 ticks per second, and in NTSC, you'll get 60 ticks per second. So, and this basically says, how many ticks do we want this frame to be on screen for? So this is our raw data for the animation frame. Now, we're going to take this and load it into our animations. So for instance, let's take a look at Johnny Cage's walking animation. So this is the animation we just looked at visually, and this is what it looks like in the code. So his walk frames, it's basically an array of 9 animation frames. And these are in the order of the properties that we have here. So the width, height, X, Y, offset, X and Y, and then the ticks. So if we go back, this is a 96 width, 144 height. We're at 672 X, 0 Y, 0 offset for the X and Y, and then it's on screen for 6 ticks. So we build out all of these frames of animation for each possible animation that they can do. Then this is fed into the sprite animator. Okay, so we're looking at the animate frame function, and the first thing we do here is do a check on the position X and Y. And essentially that is, I needed a way to track the position of the fighter on screen, which may not always be where the sprite itself is. So like I said, there's those hitboxes, and that's what the code or the logic side of the game is actually using to handle the fighters back and forth. It's not actually using the sprite on screen that the player's using to see where their fighter is. So this just has a way to differentiate where the position is for that hitbox versus where the sprite is on screen. And then we're actually updating the sprite with all of those properties for that animation frame, such as the width, the height, the graphics base, the X and Y location. All right, so here we're taking a look at the update sprite animator function, and this is called every game loop. So this is constantly being called. And the first thing this does is call the animate frame function, which we just looked at. So we can see it's taking in an animator, which has that sprite index of which sprite are we animating, the current frame, the animation frames, so what animation are we playing? Are we doing an idle animation, a walking animation, a punch, things like that. Okay, and then all the properties for that animator are being passed in. Then this is the actual handling of the animation itself. So if the rap ticks, which is the current, that's that heartbeat throughout the game, if that rap ticks is greater than or equal to the last tick, so the last time the animator ticked, plus the number of ticks in this animation frame. So basically if we said, I want this animation frame to be on screen for 10 ticks, if that has lapsed, now we do a check. If we're not playing the animation forward, meaning we're playing the animation in reverse, then the current frame gets decremented. So we're going backwards. Now this is just a little check to see if the current frame is less than 0, meaning we've run out of frames of animation. So if we're looping, then I'm going to say the current frame is now equal to the last frame. If we're not looping, I will just stick to frame 0, meaning that the animation is complete. For example, like we said, if Johnny Cage is ducking, that isn't a looped animation. So the last frame of animation is going to be him ducking, and we will remain at that frame. Now, the else case for this is if we are going forward, so that we want to increment the frame with each count, and then we do a check for the end frame. So if we're at the last frame, if we're looping, we're going to go back to frame 0. If not, we're going to stay at that last frame. And then finally, I update last ticks equal to wrap ticks so that we've kind of updated our timer so that the next time around we can check versus that last ticks, and that's for this check right here. And then finally, the last part of this that I kind of piggybacked off of the texture atlases and those the way to animate these frames, I needed a way to link the animation with a way to damage the player. So as I said, the fighters on the back end are just these hitboxes. Basically, each fighter has 3 hitboxes. They have a body hitbox, a lower body hitbox, and then an attack frame hitbox. If that attack frame hitbox hits the other player's hitbox, either the body or the lower body, that's how damage is dealt. But I needed that to sync up with the animation. So I came up with this concept of an impact frame. So in this structure, all we need is to say what frame of animation is doing the impact. So let's say Johnny Cage's punch is 5 frames of animation, but the first 2 frames are just him kind of gearing up for the punch, and the 3rd frame is the actual punch itself. Well, that punch, that is the impact. So in that case, frame 3 would be the impact of the punch, and then the next 2 frames would just be him pulling back. So that frame 3 is when we're actually going to show the hitbox for the attack. And that's when we do the check to see, is Johnny Cage's hitbox hitting the other fighter? And if so, then we, show the blood, show the damage, all that good stuff. And that's as simple as we specify the impact frame and then give the hitbox itself for the attack a relative position X and Y. So relative to Johnny Cage's position, where is the attack frame for the punch or for the kick? So, and that's loaded up here. So here we can see Johnny Cage's low punch impact is at frame 2, and then it has a relative offset of 62 on the X and 30 on the Y. So this was, once I had this concept, these are really simple to build out, to say on this frame, move the hitbox here, and then we can check for those collisions to actually deal out the damage. So anyways, this was pretty cool. This was my first, as I said, this is the first time I've built a fighting game. I've built side scrollers, I've built puzzle games in the past, but never actually had to deal with melee combat. It's always been like firing a gun, which is much easier to check for collisions. Is if you're firing a bullet, did that bullet hit the enemy? If so, then, take out damage, things like that. But the concept of melee combat where you can actually block, throw punches, kicks, where it's not just projectiles, that's something I'd never tackled before. I'm not sure how the real Mortal Kombat tackled that, but I know how I did it, and it seems to work pretty well. Okay, so the last thing I want to show off is kind of a big breakthrough I had with Scorpion and Subzero, in that growing up I always heard the term palette swap, that Scorpion and Subzero were just a palette swap of one another. And thus far in the game, I still had Scorpion and Subzero as separate sprite sheets. So they were their own sprite sheet, which meant that there was a lot of duplicated data. So really the only difference between Subzero and Scorpion, aside from their special moves and their fatalities, is their idle stance. Subzero has his arm down at his chest, and Scorpion has it up next to his head. So in consolidating these, I had to basically make Scorpion Sub-Zero's colors or make Sub-Zero Scorpion's colors. So I decided to make everything relative to Sub-Zero. So as you can see here, we have Scorpion's frames of animation, but colored as Sub-Zero. And what this did was allowed me to have everything in one image for both fighters. Then I can bring in the concept of a palette. So for example, this little image, this 4x4 image, and this is a tiny little 4x4 image with the 16 colors that we need for Scorpion. I can then take this and load it into the CLUT, or that color lookup table that we talked about in the last video, and I can change the colors of the fighter. So it really is just a palette swap at that point. And this also means that I can bring in these colors and make Reptile. So it's a big breakthrough. We now have one sprite sheet for all the ninjas. And this tiny little 4x4 image can be brought in to completely switch up the palette. So to see this in action, now we can see this is an example of Subzero, Scorpion, and Reptile using Subzero's idle stance animation. And this is cool because this opens up the opportunity for us to have another Jaguar exclusive feature, which could be our very own ninja that only exists in the Jaguar version. So I'm thinking maybe like a red and black. I know Ermac was red and black, but he wasn't in the first Mortal Kombat. He was rumored to be, but didn't actually exist. You know, obviously we're limited to whatever the animations are for Sub-Zero and Scorpion, but we could do something pretty cool with it. Make up a new fatality, have fun with it. So yeah, so I'll be putting out a Patreon poll for that soon as well. And then finally, for my patrons at the true tester level, as I mentioned, I'm building towards a pre-alpha release. Basically, all the functionality that I'm putting together now are for this pre-alpha. In the pre-alpha, I need to have all the fighters available, a basic move set so that you can kind of get a feel for the game. I do have some things to finish up. I want to have more of the basic moves, like the uppercut, the sweep. These moves are critical to Mortal Kombat. They need the ability to jump, and then I need to fix the camera panning back and forth. Once these elements are all complete, and the game feels pretty good, the next step is to test it on real hardware. So I have my game drive ordered. I've got a Jaguar. I just need a game drive so that I can test it on the actual hardware. Once all of these things are solid and the game's good, I'm going to be releasing a pre-alpha so you guys can test it. You can give me your feedback, report bugs, all that good stuff. I don't have a timeline of when this will be available, but I'm working feverishly towards it, and just know that it's coming soon. So anyways, that's a quick update of what I've got. I appreciate you guys following along, giving me the encouragement in the comments. I really do appreciate it. So I'm still super excited about this project. I can't wait to get back to working on it. And that's all for now. I'll keep you guys posted, and until next time, we'll see you. Gold-plated Scorpion. Love it. Whee! Crap, that's not right.